let me explain what will happen when we run this program. They will come here. They will configure these two pins as input and output pins because they are used for reception and transmission, right? Then baud rate high we are selecting. We configure the baud rate at 9600. We are configuring the USART as asynchronous mode. We enable serial port. We disable global interrupt, peripheral interrupt, transmit interrupt, RC interrupt. We disable all of them. And then we also disable this 9-bit transmission. And we also disable transmission as well as continuous receive. That means transmission, reception, both are disabled very initially at the beginning. After that, what we do, once we initialize that, we put 65 to the TX register, then we enable the transmission, then we enable the continuous reception, then we enable the global interrupts, then we enable the peripheral interrupts, then we enable the receive interrupts. All these steps are done.
Yes.
Then we are waiting infinitely in a while loop. While we are waiting, if we get any overrun error, we simply reset the port because that is more common. Sync problem, if there is a sync problem, we reset the port. Okay, if your data is received from the serial port, what will happen after the successful reception of data? We will get RCIF flag is set to 1 and program counter will load to this address. We are coming here and we check whether that flag is set to 1. If it is set to 1, we read the data from receive register and put that in the TX register. Moment we put that in TX register, halas, the program, that is task is over. TX register will shift that to TSR. From TSR, it will go to the line. So whatever we are transmitting from the laptop will come back to us as a result. Understood?
Yes, sir. I got it.
Got it. No. So let me connect this to Flasher now. We'll compile and flash this.
Sir, this whenever we are checking this RCIF, right, sir?
Yeah. Whenever this, yes, come on.
It's 1. Whenever
when it will become 1?
Whenever we are receiving.
Whenever we are receiving, not like that. We are receiving bit by bit. When the receive complete 1 byte is received, only then that bit will be set to 1.
Yes, sir. So at that time, the program counter will load.
See, let me explain you.
This part.
Here initially we are coming after initializing all these things. We are waiting here infinitely. Yes or no?
Yes, sir.
Infinitely we are receiving. If there is an error in the reception, we reset the port. That is what we are doing.
Correct, sir.
Let us say, as we enable the reception where we have enabled CRN equal to 1. So we continuous receive enabled. As we enable the reception, if something is coming from outside, let us say the laptop is transmitting some character that will be received by the microcontroller. Yes or no? Because that is possible. It can receive. While it is receiving serially, if it has received 1 byte completely, if it has received 1 byte completely without any reception error, at that moment only RCIF will be set to 1. And then program counter will be loaded with this address. The address of this function.
Yes.
Actually, this function will go and sit in some part of the memory in program. So to that address, program counter is loaded because we enable the interrupts. So what we have in that address? In that address, we check whether RCIF flag is set to 1, meaning that reception is complete. Yes, it is complete. If it is complete, then we read the data by 2 times. We are reading the RC register because in that only we have a content. This is just a flag. We read it for 2 times because it is double buffered. Once we read it that by 2 times, this RCIF flag will be set to 0, back to 0. As complete reception has happened, it becomes 1. Once we read the content of RC register completely by 2 times, that flag will become 0. Then we push the data that we read from the port to the TX register of the microcontroller. When we push the data to TX register of microcontroller, the TX register microcontroller will try to transmit. Okay, when it is transmitting serially, the teraterm that we have in the laptop will get the data serially and will store it in its register, and then it will display that in the teraterm screen.
Yes.
Understood?
Yes.
Okay, as we made the RCIF to 0, after making the RCF 0, we are returned. Where we return? We return to this infinite loop, because there only we called interrupt service routine. We will come back to this interrupt service infinite loop. In this infinite loop, what we are doing? We are simply waiting. If there is any error or reception error, we reset that serial port. Right now, we reset the serial port for correct reception. Apart from that, we are doing nothing. Understood?
Yes, sir.
Now you are clear, right? How this program works?
Yes, yes.
Any other doubt you have in your mind now, as of now?
No, sir. Currently, no.
Shall we flash?
Yes, sir.
Okay, let me flash the software now. Before that, we have to build. Let me connect the controller first. Right, I connected the controller now. Then I have to open the flasher. Here we have our flasher. Where is that? Right, so they say pick device found. So what we do, we read it. It is reading perfectly. Then we erase it. Then we write the empty words. Then we load the X file. I think we didn't have an X file as of now. Right now, we have to build. Okay, anyhow, let me cancel this. Okay, everything went well. Now it is time to flash. Import X. 748. Open. So now we have very bigger program, no? Previously we used to have only 2-3 words. Now we have a lot of words. Okay, no problem, because it is big. The compiler, it includes a lot of codes to serve the interrupts. Then after that, I just write it. Perfect. Now I flash the software. Now I bring it back to my controller board. Right? So I connected the controller now with the board. I turn on this motherboard. Then I have to open Teraterm. Now I connected here. Install. Yesterday only I installed the driver. It was okay. Now it is doing the job. I think I have to connect it only a particular folder. Okay, perfect. So it is waiting infinitely now, so that I am typing D, but I am not getting D, meaning that my program is not doing the job. Yes or no? See here, I am pressing A, I am not getting A. Yesterday we got what we typed, meaning, I don't know. Let me check the cable first, whether there is no issue with the cable. For that, I just short 2 and 3 because they are, it appears to me, okay. So I just short TX and RX pin of the cable. So it is echoing what I typed, meaning that there is no issue with the cable. The port is properly detected. But after that, I just connect this to microcontroller serial port. Okay. Now I do see here, I am getting it. Yes or no?
Yes, sir.
So whatever that I type, I get it back. Now I turn off the microcontroller board. When I try to do that, it is not doing it because board is off. There is no one to receive. So again, I turn on the board and then I try to type something. It is doing the job. Understood?
Yes, sir.
So interrupt program is working now. Is that clear to you?
Yes, sir. Clear, sir.
I do the other way around. What I do, instead of doing this, I just issue a reset, board reset. After issuing a board reset, I try to test the program. It is working fine. And then the third method is turning off the main power to the adapter. So I turn off the main power to the adapter. After that, I try to type. I'm not getting anything because there is no receiver is not activated. So again, I power it off, power it back. Then I type something. I am getting it. So in all the test, it is pass. Got it? So our interrupt service routine is working fine.
Yes, sir.
Understood?
Yes, sir.
Okay. So I want end today's session with this. Let us discuss about analog to digital converter. I think these two things are enough for serial port. We will cover other things that we have in serial port one by one when we are covering other topics. Next session, we will study about how to use analog to digital converter, meaning that is what the one which will recognize and digitize real-time signal. So we will learn about it, how to do that. Okay, now.